egoTeach's solution for global primary education is inspired by research in cognitive and educational science, combining the psychology of development, motivation, and learning. The impetus for our approach is that out of hundreds of studies, the strongest educational intervention found so far is to give each child a personal tutor. Here, children are actively probing and updating their knowledge with the support of immediate and personalized feedback. Although one-on-one tutoring cannot be scaled worldwide, the primary benefits of personal tutoring can be integrated and even enhanced using tablet technology. To most effectively use tablets, we must abandon the classroom model of education based on the Aristotelian idea of students' minds as a tabula rasa, vessels waiting to be filled with knowledge. Instead, learners should be seen as budding scientists, actively creating hypotheses in their minds and testing them through their actions. At first, guided only by their intuitions, their hypotheses will often be wrong, but through immediate and interpretable feedback, they can be led to learn concepts of increasing complexity. Active sense-making is a process that unfolds as a sequence of mental steps. Learners generate possible hypotheses to explain their environment, and then gather new information via interaction to test the hypotheses. Upon seeing the outcome of their inquiry, they must understand and update their beliefs accordingly. The cycle continues as they achieve better and better understanding of the world. The stages of this loop mirror the process of scientific reasoning engaged by scientists. Moreover, this is individualized learning, where children can target the specific questions needed to fill gaps in their knowledge. Using an adaptive AI engine shared across games, the egoTeach suite of games intelligently adapts the sequence of material given to the student, just as a tutor would, but with the addition of real-time game dynamics to deliver precise content and feedback. The AI continuously probes the student's knowledge in the games, reprioritizing content based on correct and incorrect responses, rooted in distributed practice effects from memory studies. Combined with continuous positive and negative feedback and reaction time and accuracy data that is updated and integrated across the games, the AI engine subtly personalizes when and what content each child needs to practice to master each new skill, introducing new content and skills at the appropriate time. Our games are designed to be learned via active exploration, trial and error as in science, and are directly built upon the underlying concepts of math and literacy we are trying to teach. These are not just gamified standardized tests. Our use of universal nature themes allows children from diverse cultural backgrounds to accurately induce and bootstrap their understanding of the concepts. egoTeach contains 8 primary games for teaching the core literacy and numeracy concepts. 2. In the Ladybug game, learners hear a number and must identify the correct number from several options. Learners then tap the target ladybug the correct number of times, receiving intuitive audiovisual feedback as they learn the link between numerals and quantity. Incorrect actions slow the bug's movements, result in fewer options on the next round, and increase the likelihood of seeing that number again soon. Successful interaction results in more options, faster speed, and a decrease in the number's priority, reflecting the child's improved knowledge state. Over time, the game proceeds to teaching sequences, counting by intervals of 2, 3, and so on. Star points earned during play reinforce the concept of counting. 7. In the strategic ant rescue game, learners hear a target number and attempt to move the correct number of ants, dispersed in different amounts on a set of small lily pads, to the large lily pad where they find their food. Children learn addition, including the standard notation, shown after each subproblem is completed. This game implicitly teaches the commutativity of addition. It clearly doesn't matter which small lily pad is the source and which the destination. It is self-directed in that learners choose their own paths to move ants between lily pads, and there's no time pressure. Correct and incorrect responses adjust the AI's estimates of their knowledge. Game dynamics adjust with responses. Incorrect responses decrease the maximum number of distractor lily pads. Correct responses increase them. Subtraction problems are introduced and appear more often based on correct responses. In the nest building game, a quantity of eggs appear, and learners need to draw a nest to hold that number of eggs. It's not that interesting for small or prime numbers, but they're good for learning the mechanic, which teaches the geometric interpretation of multiplication. They intuitively see that multiplication is commutative. Length and width are interchangeable dimensions. As always, responses are used to adjust the difficulty. Pilot testing in Brazil and Tanzania showed that although this game is initially a challenge to understand, children persevere because they love being able to tap all of the eggs when successful, which further reinforces the link between number and quantity. To teach letter identification, a letter is named and the bee races them to the flower with the named letter. A straight path is good for initial learning, but in later stages the bee's path wanders. The bee speeds up or slows down depending on response correctness, and more or fewer options are shown. Both upper and lowercase letters are practiced. A version of this game, unlocked after the alphabet is learned, is used to teach spelling. A word is spoken, and the bee is directed to pick up the correct letters. A spelling bee, so to speak. We start with very common short words and gradually increase orthographic complexity. We've recorded the 1,000 most common words in Kiswahili and English. This game teaches spelling and vocabulary. It's similar to the common game Hangman, but without the macabre theme, and with only limited availability of letters. The game introduces extra letters as they advance. If they guess an incorrect letter, the hidden object is partially revealed, giving them a chance to sound it out. The game starts with 50 animals we've illustrated, but proceeds to work with the other 950 common words we have recorded. Words are repeated over time at increasingly long intervals, in accord with the spaced repetition strategy suggested by memory experiments. The classic memory matching game can be used for additional practice of several concepts, including upper and lowercase letters, as well as shape names, simple addition problems, and sight reading of short words. The amount of time given to find all pairs and the total number of pairs is adjusted as a function of performance. For practice writing, we provide a simple sandbox in which they have the opportunity to draw whatever they want, but with a subtle hint to practice writing the alphabet at first, and later audio prompts to try writing animal names. Taking a constructivist approach, we will also leave a basic word processor and have plans for other sandboxes to enable children to use their new knowledge to create. A separate app contains a library of open-source, illustrated children's books organized by reading level that can be freely chosen from. When tapped, sentences will be highlighted and read aloud, providing assisted practice as required. Page indicators reinforce the concept of a number line. We are recording more books as well as simple illustrated science lessons we've written to introduce core concepts of physics, chemistry, and astronomy. Our modular design makes it easy for others to also create and drop in additional content with or without recorded audio. We've paired with a small literacy NGO in Tanzania to create a catalog of stories that celebrate local culture, and are building an authoring tool so children can write and illustrate their own stories. We are very excited to grow this library to keep children actively engaged with literacy and math concepts learned from the egoTeach games. Funded by a grant from NYU, we went to Tanzania this November, pilot testing our apps in a public school, both validating our core principles and giving us key feedback for refinement. Our pilot testing in Tanzania verified that children can learn the games without instruction by exploring and testing the features of the apps. The children liked the games they played and played them daily for over an hour. We saw that although some children prefer to work alone, others share and work together and seem to enjoy teaching each other how the games work. They quickly figured out how to switch games and eagerly tried them all, and continued to switch games over the 5 days of intervention. When we surveyed the 23 children about their favorite games, at least a few children named each game, and one child said all of them. We collected over 20,000 trials of interaction data during the intervention, and will use in-depth analyses to further improve our apps. Although egoTeach is a complete ready-to-ship product, we have dozens of ideas for new games, narrated lessons with comprehension questions, and for scientific studies testing various aspects. For example, comparing self-directed learning to partially AI-directed learning, where games could be unlocked or locked depending on learners' proficiency and recent use of them. Having completed piloting in Tanzania and Brazil, we are applying for grants to fund scientific testing in the US, the Netherlands, and abroad via national funding mechanisms, as well as NYU's Global Ties International Research Center for Children's Education. We are eager to keep strong ties to both basic and applied research, even as we develop the business. George has 8 Bachelor Artificial Intelligence students working this spring on new games and on improving speech recognition and synthesis in Swahili with deep neural networks. Kat and George are organizing a special issue on the topic of cognitive science-inspired educational games, and Hugo is eager to join George in the Netherlands to do a PhD continuing to build, test, and improve egoTeach. In summary, egoTeach is a collection of games presenting the core literacy and numeracy concepts in a way that enables self-teaching, reinforced by a shared content engine with an adaptive AI backend to reprioritize content. The difficulty of the game dynamics adjusts to the learner over time, keeping them engaged while they still maintain the freedom to choose different approaches to learning in the various strategy and action games. Enabled by the Global Learning XPRIZE, egoTeach is ready to ignite evidence-based improvement in primary education worldwide. Thank you for your consideration.